All right, we are running. All right. I don't know why I'm on that page. Let's go to the right page here. All right, here's where we're actually going to be. We're going to work on firmware a little bit today. It's not a thing that you have to ever deal with. You can get away with never touching your firmware at all, and just printing with your printer right out of the box and be almost perfectly fine. But there might be reasons why you want to go in and completely change the firmware, where maybe you want to change to a totally different style of firmware, or maybe you want to add a feature to your firmware. Those might, or you change your board. Maybe you change the entire board out and you want to put a specific firmware on that new controller board. But a lot of people, there's not a good reason to go in and do anything to your firmware. But I'm going to show how to do it, because recently they've made a couple of changes where, particularly on these Ender 3s, where you can get hung up on some things that you wouldn't know there were even problems. So I'm going to show how to do it. In fact, when I practiced this one last night, and it took me forever to figure out what little tiny mistake I was making. It was a silly mistake. It wasn't even one I would think mattered, but it did matter. And well, I'll show you what that one was too. So let's go here first. So this is a control board from a previous printer. You can get a little closer to it, I suppose. And what this thing does is it takes in power. So you get power in over here from your power supply. These printers pretty much just use a computer PC style power supply. So you get 12 or 24 volts in, depending on what kind of printer you're running. And it'll distribute some power. So these will distribute to the hot end and the bed. And what else would it distribute to? That might be the main things that need the large amount of power. Is you have to heat up the heater cartridge in the hot end, and that takes a lot of power. And heating the bed takes a lot of power. So they get their power supplies. You have a lot of limit switches over here for the printer figuring out where it is as far as hitting a limit switch goes. So kind of when it does its homing routine. You have a little port for your monitor, your LCD panel. You have some places for fans to plug in, because there's at least 2 fans on your printer that are controllable, sometimes 3. Also the fan that is on the power supply, it's not the power supply, the control board itself, you can have that one controllable. There is the fan here, this fan. It's not really controllable, it's just on all the time. When your printer's on, it's on. You really wouldn't want this one to be controllable, because if the printer is on, then this one is going to be better if it is on in the event that you turn the hot end on, because you wouldn't want the hot end to ever heat up without this fan being on. And so it's just wired to be on all the time when your printer's on. Technically, you could get away with only turning this on when the hot end begins to heat up above a certain temperature, but it just stays on. And that's probably for the best, because that's an easy check to make sure that it's actually running correctly. These are outputs to the stepper motors, and here you have the stepper drivers. So all of that to kind of get down to these stepper drivers. Underneath these heat sinks are the actual drivers themselves, and they were a piece of the issue with the Ender 3 version 4.2.2 board particularly. Other boards may not have this issue, but the 4.2.2 board, you can get multiple boards that are Creality 4.2.2, and they have different stepper drivers on them. And you can't tell by looking at it because they're covered up with these heat sinks. But they did do something that does help you out. You just have to know that this is what they did. So let's go into my board over here. I've already opened it up, so we don't have to spend any time. So my board is down in here. There's the stepper driver right there. This is, I don't know if I can get this out of the way. There we go. You can kind of see this is a 4.2.2 board. Probably shouldn't be probing down in there with metal pieces. It's not on right now, but still. And so I don't know what drivers are underneath these heat sinks without pulling the heat sinks off. But this label right here written on top of the SD card slot in just some kind of marker, that's the letter C. And you can take that letter and cross-reference with this web page. Let's see here. I'll put this link, if I remember to, I'll put this link in the video description so you don't have to hunt for it. But these decode the letter that is written on top of the USB slot, because otherwise you can't tell a 4.2.2 board with these TMC drivers from the 4988 drivers. So the C is the HR4988, so it's a kind of a cheaper version of this A4988 driver. Why that matters is because they are different drivers. The 988s are, they're functionally the same. They're not the same. They're made by different people, and the HR version is quite a bit cheaper than the A version, and it's a little bit more noisy. These TMC drivers are silent drivers, and so they need a little bit different set of commands to operate correctly. And so if you install firmware that is meant for a TMC driver, but you have the 4988 drivers, you're going to have problems, and vice versa. So you do need to know which one of these you have. I believe, but I'm not certain, I believe that if you have the Ender 3, just the 3, not the Pro or the version 2 or anything like that, but the Ender 3 with a 4.2.2 board, you're probably going to have the 4988 drivers, the non-silent ones, so the little bit noisy ones. If you have the others, like an Ender 3 Pro or anything like that, and it has the 4.2.2 board, you're probably going to have the TMC silent drivers. At least you should. So I don't know that that's 100% true, because I've gotten kind of mixed matched parts. It used to be that these all had this version 1 board, this 1.1.4 board, and these were definitely not silent drivers. And now that they are pretty much all the Ender printers come with the 32-bit version 4 boards, they are still producing some of the lower end, entry level, I guess. They're all sort of entry level, but the lower end Ender 3 printers, the ones that are just labeled Ender 3, and I think they all have the non-silent 4988 drivers in them, but I can't guarantee that. So you probably should check your board number first of all. I don't think any new Enders are shipping with this older board. I don't think that's a thing anymore, unless you get one from a reseller that has some really old stock going back to last summer, basically. So I don't think you're going to run into one of these unless you buy an older Ender 3 kit or a used Ender 3. So you probably don't have to worry about this particular one, but you still have to worry about when you buy a 4.2.2 board, which type of driver is on there, the silent ones or the noisy ones. And you have to be careful. Sometimes when you order these printers, they will word it in a way, and they'll use the word silent, but they don't mean it in the silent driver type of meaning. Let's see if I can find where I bought this one. And I think there's an example there. So this is a Sainsmart Ender 3, but the cheapo one. Where's it at? Maybe they don't even have it anymore. I don't think they... Oh, here it is. It's just moved around on me. Let's see. Well, I don't see it now. Let's see if I can find... Oh, yeah. So here they have they're talking about the wheels and the nozzle and gliding smoothly and silently. So a lot of times you'll see that silent word and you think you're getting the silent drivers. But this is talking about like the wheels rolling on the rail are not noisy, which I really am glad that's true, because that would be kind of a sad machine if the wheels rolling around were not silent, or at least really quiet. So you do have to be careful that if just because you see the word silent or silently in the description doesn't mean that you have the silent drivers. So silent drivers are a different thing. All right. So what you have to do to act, oh, I wasn't showing you the picture. I was just looking here. It says the nozzle is gliding smoothly and silently on these wheels, blah, blah, blah. That's what I was talking about, that this word silent doesn't necessarily refer to the TMC drivers themselves. All right. Now, how do we upgrade the firmware? So on these old boards, if you have one of these old boards, are not a 32-bit board, you have the old 8-bit boards, then there's a different process. And a lot of those boards, particularly the Ender boards, did not come with what's called a bootloader. So that's a piece of software, firmware that's on the chip that lets it accept new commands, new firmware. And there was a whole process of having to install the bootloader and then install the firmware. Assuming you don't have one of the 8-bit boards, then that is not necessary anymore. So I don't think anyone is going to have one of these older version 1 boards unless you really do have an older printer. If you do have an older printer like that has one of the 8-bit boards that it won't accept firmware, it probably means it needs a bootloader. And there are plenty of videos. I've made videos as recently as probably last year, maybe 2 years ago, that have how to go about installing a bootloader. It's not terribly hard, but you do need an Arduino and some wires. And so there is you actually wire the Arduino into your existing board, upload a bootloader to your board, and then you can upload firmware to it. The new 32-bit boards, it's a much simpler process once you get all the configuration right. So which firmware might you want to put on there? I am going to use, and I generally use this one, but I'm going to use one from TH3D, the Unified Firmware. So if you type in TH3D UFW, you will usually find it. So here, there are 2 big branches of Marlin. Marlin is the firmware that I typically use on these printers. We will use at least one other firmware, and I'll show you maybe another firmware throughout the quarter or take a different approach. But Marlin is probably the one that you're going to want to use unless you've had quite a bit more experience, or you really are wanting to get into tweaking every little thing on your printer. You'll probably use Marlin. And there's Marlin 1 and all of its lineage, and Marlin 2. The 32-bit boards need the Marlin 2. So this Unified 2 firmware is the one that I want because that refers to Marlin 2. And so I click here and it takes me to this page. Unified 2 firmware is live, Ender 3. Now it doesn't say Ender 3 just by itself here, but that's okay. There is the version 4.2.2 board support. That's good. And so click here to head to the site to download this. And they have built it for several different printers. So these are all ANET, Artillery. There's some Crealities, but these are CR10s. So let's go to the next page. All right, here are Creality Ender 3. So there are a lot of them, and you do need to pick out the one that looks right to you. So Ender 3, but this is for the Melody board. That's a different board. Ender 3, SKR E3. We'll actually put this board in our printer later this quarter. It is a nice board. If you already have the silent Ender 3 or like the Ender 3 Pro or whatever, then you may not gain a whole lot by using this SKR Mini board. But I actually will gain some on my printer. Creality Ender 3 and 3 Pro version, or for the 4.2 point anything board, that's the one that we need. So you click here and you will be taken to this page. I just guess I didn't click it right the first time. And then it gives you a little bit of info. Do you have an Ender 3 with the 4.2.2 board? There is a 4.2.7 board also. I don't think you're going to find any plain Ender 3s with that board in it. At least I haven't ever seen one. So they also, this company does sell their own products, and so there are some of these, like the Easy Able kit. That is a product for automatic bed leveling that they have, so you could purchase that. Make sure you're not using the Melzy board. Here, download Unified 2. So Unified is, the way they approach their firmware package is, it is unified in the sense that it could handle a lot of different printers, and you you activate the individual printer that you have, and the rest of the firmware that's written, the code just doesn't, it gets ignored because it's not for your printer. Now it looks like they've taken a slightly different approach here, where they have grouped them together. So this unified firmware isn't for just any printer. It is for the Ender 3 or the Ender 3 Pro with this particular board. So they are kind of narrowing it down, but they still call it unified firmware. So what you do is you download this. I've already done that. It's not a very big download. And then you need to set up what's called VS Code. So this is Visual Studio Code. They have an entire, I'm going to open this in a new window here. They have an entire setup routine for here on how to get it set up, and where you can download it from. I assume you probably don't already have Visual Studio Code downloaded, unless you have already done some firmware work, or maybe you've just done some coding somewhere. This VS Code is not just for printers. It's actually a coding environment for all sorts of languages. So you download that, and then here's the official setup document. I don't want to actually do that, so it's not particularly difficult. It basically walks you through how to install it. Most of the time, you just take all the defaults. Let's see, I'm making sure that there's nothing hidden in here that you also need to know. No, this, if you follow these instructions right here, it pretty much gets you set up with the VS Code. And I don't think there was anything there that was anything except take the defaults. Then it goes through installing this platform IO. You also need that in order for the firmware to actually work, to be compiled correctly. So you do have to, it walks you through how to install that once you're in VS Code. I've already got that installed, so it won't do anything. Basically, it goes and goes online and gets the platform IO and installs it into your VS Code. Python, so it shows you how to install Python. So there is a series of events of things that you need to accomplish before you can actually get the code, the firmware compilable. You don't have to do it this way. There are pre-compiled firmware, so it may be one pretty popular thing that people do is they add an automatic bed sensor like the BL Touch onto their printer, and there are pre-compiled pieces of firmware that do just that, and you don't have to go through any of this VS Code. If all you want is to enable the new piece of hardware, the BL Touch, the sensor, then there are probably going to be a pre-compiled firmware file that you can just download the file itself, put it on the SD card, and put it in the printer. But if you want to change anything, change any options, or have a little bit more control, then this is what you have to do. You have to go through the VS Code, install the platform IO, install Python. None of those are terribly complicated. You know, all these pictures make it look like there's a lot going on, but these pictures are literally showing you every click that you have to make. So this guide is pretty thorough when it comes to how to get ready to compile your own firmware. We'll do that part today. So let's look at that. Let's go back to where I was. I had just downloaded the Unified 2 firmware from TH3D for Ender 3 with the version 4.2.x board, which that should work for what most Ender 3s are going to have. I've already set up the VS Code, so if you don't, that is the next step to do. Actually, they say then download the firmware. I guess I did those out of order. Extract it. This firmware file here is a zip file, so you extract it into a regular folder. And now we go to VS Code. So let's open that. So here, actually, let's unload. So I'm going to close the folder that I've got open right now. I don't know what changes I made, so I'm not going to save them. I don't remember what it was. So here, the first time you open Visual Studio Code, it will probably, down here in the bottom, it will probably go in and check for updates. It might install some new packages that it's found to update maybe the platform IO. This is the platform IO quick access button. And so it might have been updated a little bit. So it'll probably spend a little bit of time updating things. And I also have this auto build Marlin in here. We don't need that for this firmware. It can be useful though. And it's another plugin where you could go and you can search for different plugins. All right, let's open our folder. So File, Open Folder. You don't want to open a single file. You're going to open this whole folder that you just extracted. Let's see, I put mine on the desktop, and here it is. I also have the Marlin. I'll show you how to do the Marlin one also. But this one that I am doing is Marlin. It's just been tailored by this company TH3D to do specific things or to be organized differently. So I'm going to use that one first. So here's installation guide in case you don't want to go back to the web page. There's stuff in here. There's LCD firmware if you have a LCD that takes firmware. I don't on this printer. And in here is the firmware. So if I click this, you'll see here's this Marlin folder. I can see that. So I'm going to select this folder where Marlin is visible. Not the actual Marlin folder, but this one. And now I get basically that folder is open in VS Studio, or the SS Studio, I think. VS Code. All right, so I want to go to, all right, see there it did, it opened the platform IO because it knows it's going to need that to deal with this. So let's go back to this configuration.h file. So this is the main file when you're talking about modifying your firmware. This is the main file you're going to be doing any kind of editing in. There are other files. If you look over here, there's a configuration advanced.h. If you've ever done any Arduino, you remember these .h extensions. Maybe you remember them. They're kind of like little libraries, right? Or include files. And these boards are basically fancy Arduino. They're running off of an Arduino base code system. So a lot of this, if you've ever done any Arduino coding, it's going to look very familiar when you look at the actual code. So the configuration backend, rarely will you need to go in there. There are some boot screens that you can edit. I don't think if I click on them, it's just going to be, you could potentially, actually, if I scroll over, you might be able to see, yeah, there's the logo that they've planned out. So basically, they're just putting dots and then octothorpes to make an image. And you can kind of see it in here if you can see all the zeros. And then in here, there are some different codes. That's because they are, these aren't all octothorpes. I think they did that over here just to kind of show where they were patterning things. But these are different symbols. And so basically, they're just making a picture out of pixels on the LCD screen. So you could go in and edit your own custom boot screen if you wanted to go through and edit this thing. The advanced, like I said, it does have some things that you occasionally will work on, but it's the configuration.h is the one that you will do most of your editing in. So how you do on the unified firmware. So first you have to go in and pick the particular board and printer that you're going to use. So by default, all of these are commented out, right? And this is the very top of the configuration.h. So there's line 1 right there. And it actually goes and, it gives you a little comment on, if you're not sure what to do, go check this website out and read the instructions. And then it gives you another reminder, only uncomment things in one printer section. So this is a unified firmware code. So it has different sections for different printers. And you only want to uncomment the things in your printer. Don't uncomment the Ender 3 section and then also the Ender 3 Pro section, because it'll get confused. So Creality printers with a 4.x board, that's us. 4.2.2 board, that's us. We're not uncommenting things down here in the 4.2.7 board. So we're in here, and then we look, all right, we have an Ender 3 422 board. Other options are Ender 3 Max, Ender 3 version 2. So all of these printers have this 4.2.2 board. I want this one. So the plain, well, for me, because I have the plain Ender 3, nothing Pro or version 2 or anything, but I do have the 4.2.2 board. Technically, that is enough that all I have to do. But I want to go through and add one other thing, or at least show you one other thing, because it is possible that you would want to add this one also. Here is a little mention of those drivers, the TMC versus the 4888 drivers. I can't remember the exact number. I wrote it down. Yeah, 4988. And so if you do happen to have one of the 4.2.2 boards that don't have, that, let's see, where's our little list, that have a A, B, or maybe even an H. I don't think it's going to have the H, but an A or a B written on it. Then you do want to define the fact that you have the TMC drivers in there. So you would uncomment this line. I do not have that, so I need to leave that commented. Mine has the old drivers in it. But if somehow you do have the new drivers, an A or a B written on that SD card slot, then you also uncomment this line. There's a lot of code, and a lot of it's commented out. And that's what they mean by this uniform code, where it's all in there, and you have to go uncomment the stuff that is relevant to you. I am going to, I think I'll do this. So remember, we went through and calibrated our E-steps early on. We went to here and did this process, or a similar process anyway. And it came out that my E-steps should be 97.7 instead of the 93 that was hard-coded in. So I want to include this in the firmware. If I don't, then I need to put it in somehow. When I write this new firmware on top of the old firmware completely goes away, and so I'll have all new settings. So I want to go ahead and put this, since I know this is the correct value for my E-steps for my printer. I probably should calibrate them again just in case this particular firmware somehow is driving the steppers a little bit differently. It shouldn't be, but we'll see. I'm going to go ahead and put this in 97. I'm going to put 97.7. I don't know if it can handle the 2 decimals or not. So what I'm going to do is I'm going to do the custom E-steps. So I'm going to uncomment that I want to use custom E-steps, and then I'm going to make the value. I'm not going to make it 410. I'm going to make it the 97.7. Is that what I decided? Yeah, 97.7. So I'm going to put that as my custom E-steps value. Now, sometimes you have to have integer numbers on this E-steps. I don't remember if that's true for this one or not. We'll find out. It just won't compile if I can't have a decimal here. We'll come back to that. The other thing I want to do is I want to enable what's called manual mesh bed leveling. And what that does is, so you can add a piece of hardware, that BO Touch or the EasyAble sensor or some kind of probe that goes in and actually probes the bed before your print and determines where it's at, so that it's if it's warped, it can kind of adjust for that as it's printing, or if it's slanted or something like that. and you don't need that Z end stop anymore. You can just let the probe find where the bed's at. Well, we don't have that. We will put it on later, so we will see how that works. But we don't have one of those sensors. But I can get sort of some of the same effect manually. So I can go in and map the bed manually with this manual mesh bed leveling, and that way, in case my bed is kind of warped. Remember, I think mine has a hump in the center of it, and it makes it kind of hard to print across the entire bed, because if I'm close enough at the center, then I'm too far away, the nozzle's too far away on that perimeter. So in fact, I did have a little bit of warping on that print I showed you last time. So this is a way without the sensor that I can go and kind of calibrate the surface of the bed. So I'm going to Control F and search for manual. Well, there it is right there, manual mesh leveling. So by default, this is uncommented, or this is, not active. It's commented out. But I actually want to enable this. So all I need to do is uncomment the define manual mesh leveling, and that will add an option in my printer's LCD menu to do this manual mesh leveling. Without having that extra probe. So I can do it on this printer that doesn't have any extra hardware on it. There is a note here, I will mention it, that you may have heard of linear advance, or what else is it called? I can't remember the other name for it. But linear advance, pressure advance is the other name for it. These particular boards, the 4.2.2 boards, technically they can do linear advance, but it doesn't work very well with these drivers the way they're configured on these boards. So if you're hoping to do linear advance, it is here, but I would not activate it. So I would not uncomment this line, because it's probably not going to work very well on a 4.2.2 board. In fact, I think they even give you a note of that somewhere. I think they do, but I don't think it does right here. Somewhere in the comments, or maybe in the installation guide on the web page, it tells you that the linear advance doesn't work very well on these boards. Once you've done all the edits you want to do, and I don't know that there's any other ones you might want to do, there is a power loss recovery, so it can go in and say the power goes off mid-print. It can resume after that. That is possible. It does wear your SD card a bit, because it's constantly having to write where it's at to the SD card. So you could enable that. I never do. This is most of all the code. Most of this is not actually active. You can kind of see it's all dull. Here's some that's active. Let's see. Oh, this is talking about how it's going to communicate that you're using the stock display. I assume you are. I am anyway. Most of this is configuration type stuff. You don't need to edit most of all of this. The only thing I would probably worry about is, do you want the manual mesh leveling? Obviously the right board, and then maybe the custom E-steps. Although you can leave those off and just calibrate them on the board, on the control panel. So what you do then, once you've got this set up, is there's a little checkbox down here, and you check it, and it'll take maybe 2 minutes or so. It kind of depends. Sometimes it has to go download dependencies from the internet the first time, because it doesn't have all of the things that it needs to compile this firmware, so it might have to go download some things, and then it needs to do with the actual compiling. This does take a little bit longer to compile, because there's quite a bit of code. It's not just compiling this one configuration.h file. It's taking all of the files and putting them into a single binary file that we will use to hopefully flash our firmware. So let's let that go for a bit. You'll be able to see down in the bottom, there's a little label that it's building. You'll get to, this probably doesn't mean anything other than the fact that it's moving. It means that it's making progress. There will be a message at the end that either it failed or it succeeded. Usually, if it gets through this part, it's going to succeed. A lot of times, it fails. It fails right off the bat. Something's set up wrong. You've selected an option. Maybe you've selected two options that conflict with each other. Something like that, and it will shut down right away. But it does take longer the first time because it has to download those dependencies, and then the next time it's probably going to take about 2 minutes to compile. I guess it's also affected by the speed of your computer and whatever else your computer is doing at the time. So it might actually take us a little longer, but since I'm streaming and everything at the same time, it might take a little longer. While it's going, I'll look at some other stuff over here, and we'll come back to it because it really could take 5 minutes this time. One of the things I get are these little boxes. I don't remember what they're called anymore. Maker box, I think. They're not particularly a super great deal, but our firmware finished. We'll come back to this. What this is samplers of about a small amount of filament, and you get some samples of filament that you normally would be really expensive, or maybe you don't want a whole roll of it to try out, and they send you every month a sample set. We'll look at what's in this one in a minute, but our firmware actually finished compiling and it did succeed. So now I need to take that firmware. I'm going to put it on our SD card. So get the SD card. Now this is where my problem came in. So this SD card is the one that came with the printer, and it had a couple of folders with user manuals and a couple of STL files on it, and it had files that I had put on, or not STL files, G-code files, and a couple of files that I had put on there to print. And so it wasn't empty. And I did what you would normally do. I put it in your, adapter, and then put it in the computer, and copied the binary file over to it. Installed. How you install this binary file? Let's go through that process. So back to, I've got a window covering up my screen. Back to here, in this left-hand tree, if you go to PIO, so they're normally closed. They normally look like this. So if you go to PIO, and then the build one is normally closed also. So you open it up, and then there's this STM32F103RET6 Creality. If I open that, or well, actually, if I right-click on it and reveal in File Explorer, I will get this window. And basically, it's just showing me where it put all the files that it created. So in this folder, I will get a list of folders and some firmware. Now, I actually have two firmware in here because I've compiled this more than once now. This is the one from yesterday at 11:30. Here is the one today, 8:36. And they have these different numbers after them. This is actually the date. So there's 2021, June 11th, and then the time, 8:33 and 55 seconds. Why they're doing that is, this is one of the things they've changed. The way the firmware used to work when you uploaded to a 32-bit board is it would go in and take a firmware.bin file off of an SD card and install that onto the board. The board does this automatically. That's the automatic bootloader recognizing that there is a firmware bin file on there, and install it, and then it would rename that file to something else. Firmware it had a different extension. And then the next time you put the SD card, it wouldn't reinstall the firmware because it has a different name now. Now what they do, or at least what these boards do, I don't know if all 32-bit boards do this, but the Ender 4 boards do this. They just look at the name, and as long as they've never installed that firmware name before, they install it. So, and actually, it's they look at any bin file. So it might not even be a bin file for this. Maybe you have an octopi, or you have anything that has a .bin extension. It's going to install it on your board as soon as it sees it, if it's never seen that name before. But if it has seen that name, like this one, it's already seen this name, it won't install that one. So it doesn't change the name, it just remembers the ones that it has installed and doesn't ever reinstall one with the same name. So I don't know how deep that memory is, like if it's just the previous one, or if it's the 10 previous ones, or if it's everyone ever, I don't know. I didn't bother to try and figure that part out. But so you do have to have a new name. It doesn't have to be a more current name necessarily, just a different name from anything it's ever done. They could be firmware 1.bin, firmware 2.bin, and so forth. But what they did to randomize it is this: they just add the date and time so that it shouldn't ever be the same, unless you went in and manually edit it. So you take the most recent one, so that's this one, and you put it on your SD card. So there's the old SD card, and there's that old firmware. I'm going to actually delete that. Notice also that this is an empty SD card. It is the one that did have all the folders and all of the G-code and everything on it, but it would not correctly install the firmware with any folders or anything on the SD card. So I actually went in and reformatted FAT32 system on this SD card. So I completely reformatted it, which erases all the files on it, and put my new firmware. This is the right one. Put my new firmware on there, and it's the only file on the SD card. With these SD cards also, be sure you eject them. If you just remove them, they easily corrupt. Typically, these SD cards that come with the lower end printers are pretty cheap SD cards, because the whole package is made with the cheapest components that they can make work. And a lot of times these SD cards are weak links. In fact, a lot of times I don't even use these SD cards. I get a much more reputable one. I've seen some of these SD cards, not these, but the larger ones, where it might be labeled as a 32 gigabyte card, but it's actually a 4 gigabyte card, but it's been formatted in a way that makes it think it's 32 gigs, but there's no way that you can actually store that much data on there. And what will happen with those is it will look like your file is, your G-code file to print with is on those cards, but you could easily overrun the card's memory and it'll just stop halfway through a G-code print, because the rest of the data is just not there. The card is formatted to look larger than it actually is. And so I don't know about these. That was happening with some of those larger SD cards, the actual SD cards, not the micros. But it could happen to these too. I don't think so, but still, these are generally the cheaper ones. So if you're ever having printing trouble and maybe it just freezes in a print, or it seems corrupted and you can't track it down to a mechanical problem, it might actually be the SD card. Try a different SD card. And I generally keep these pretty empty anyway, because it is possible that too many files on there can cause problems. So I've formatted this. Let me see, you can't see what I'm doing. I formatted it, and all you do now is printer's off and go in. I probably should at least sort of tighten this control cover back down a little bit so it's not going everywhere. I'm not going to put the back screw in. I'll just put these in. So that new firmware name is on here, .bin, bin, binary, and then you turn it on. And if everything goes right, it'll take longer to boot up than normal, but after 20 or 30 seconds, your new firmware should operate. So far, all right, so you can't see the screen, and I don't know if you can even see the screen anyway. I'll try to make it visible, but I don't know if it's ever going to really. Yeah, you can see that there's a glare. I don't know if I can get rid of that. It's coming from everywhere. It's right there. All right. So it looks the same, except it does say TH3D Unified Firmware 2.2.7. It's flashing here because it hasn't been homed. But the new thing in here, remember we enabled, well, let's check and see if our E-steps actually stuck. Oh wait, I think that's in, I thought it was in configuration. Advanced settings, maybe? There we go, steps per millimeter. There it is, there's that 97.6. I know you can't see it very well. 97.6. Maybe if I get closer to it. And let's see if we can change the, you can kind of see that. All right. So it did keep our custom E-steps value that we put in the firmware. And the other thing it did is in configuration, advanced settings, no, gotta find it. Motion? Oh yeah, it's in motion. All right, motion, I don't know why it's in motion, but I guess your other home information is in motion, so it kind of makes sense there. Bed leveling is in here now. We enacted that manual mesh leveling. So bed leveling is in here. And I've got the level corners, so that just, it sends it to the four corners. You use a sheet of paper to level the bed. So it kind of just does the movement for you without you having to manually move the print head around. So that's nice. The other thing it did, I'm going to have to back up to see all of this. All right, so now I'm going to do the motion bed leveling. Level bed. All right, so it homed, and now it says on the screen, it says click to begin. Let's make that not flip around all the time. So click to begin. So it goes to this point here, and my goal is that I want to take my folded over sheet of paper. This is just a regular sheet, but it's folded twice. Put it under here, and I'm turning this knob over here until I get a slight amount of drag. Right now I can't even get the nozzle, the paper between the nozzle and the bed. There we go. I don't know if I want to do this whole process on screen because there's 9 of these points. So I ended up having to raise the nozzle 0.375 millimeters. And I click it, and it's going to go over here, and I do the same thing. This one is actually pretty good like that. This one is too high, so I'm lowering it. There you can kind of see I've got a little drag. Here, this one's too tight, so I'm going to raise it. I'm not looking for like a lot of resistance. I want just a little bit. The main thing is I get them all the same. This one's way too high now. I'm going to lower it. That's good. This one's too high, so I'm going to lower it. I'm raising this one. That one's too high, or too close. That's probably good. That one's too far away. That's good. So what it did is it only did 9 points. So there may be a way to actually go in and do like a 4x4 grid. That one only did a 3x3 grid, but now it has those 9 points mapped out, and it will interpolate between the points to move this print head up and down as it goes across the bed to try and maintain a consistent distance from the surface. So it's doing the same thing like a automatic probe does, except you manually do it. Now I need to activate that in my slicer software to take advantage of it, because otherwise it's just built into the printer, and the G code isn't telling it to actually use that. But it will. I don't have to do that over and over again. If I change the bed somehow, so if I put a different surface on it, or if I think I've gotten it out of level or something like that, then yes, I do need to go change it. But I should be able to, as long as the bed stays in this configuration, it should map the bed when I print, assuming I turn that feature on in my slicer. I'll have to show you how to do that also, I suppose, in a minute. But we're kind of running low on time. So the things that I ran into were when I put the SD card, did all the same process as I did just now, but put that file on a SD card that already had other files, not other firmware files, just other files on it. It would load, it would boot up. Well, no, it wouldn't boot up. It would turn on, like the fans came on and the power came on, but the screen just stayed blue. Is this option on the original firmware? I don't believe, well, so generally no. So on the firmware that comes, I assume you mean the manual mesh option. It is not on the original firmware unless you bought it from a reseller that went in and enabled some of these things. So if you bought it straight from Creality, I don't think it is enabled by default there. It wasn't on mine, but mine didn't come straight from Creality, so maybe they turned it off for some reason. But it is available. It's going to be, in this one, it was in the motion. And then it said, what did it say? Motion, scroll down. It's a bed leveling is what it's called on this particular firmware. And it's inside that bed leveling menu with, it's just called level bed. Now I don't know if those would be the same in all of the different iterations of the firmware, if those are the same keywords, but that's what it is on this one. But it wasn't enabled by default on mine. So I actually kind of like that one. We will put a BL Touch on this one later, and it kind of makes this obsolete. But in the meantime, it's a handy way if you think your bed is just kind of wavy. And ours was a little bit wavy, so maybe it'll help us out. So the thing that solved mine is erasing everything. Actually, I didn't just erase it. I reformatted the SD card so it was completely fresh, and then put the firmware file on there, firmware, all those numbers .bin file on there, and it worked fine. And it's worked fine ever since then. And there was, I don't know why that's a case. You know, it shouldn't matter. In the past, it never mattered, but in this particular printer, it did matter if there were other files on the SD card you were using to flash the new firmware. Also, I haven't tried it, but if you try putting firmware with an older file, like one you've already used, I think that will also cause it to just load up a blue screen on your control panel and not do anything. You can fix that just by renaming the file to something you haven't used before and uploading it again, flashing it again. Let's see, we have a few minutes. Oh, let's look at what's in that box. I was going to do a magnetic bed upgrade, but I don't think we have quite enough time to do it. But maybe we have enough time to look at it. So what the kind of stuff that comes in here are kind of specialty filaments in general, and they're things that you might want to try out, like this, and it's random, so you don't actually know what you're going to get, so it's random every month. Carbon fiber PETG. So we haven't printed any PETG yet, but that's probably, once you're comfortable with PLA as printing, PETG is probably the next one to try out. It's prints at a little bit higher temperature. This one, you can kind of see it's in the 240 range, which these printers, the Base Ender 3, can print about 240, is about as hot as it can get without problems. Remember that Bowden tube this tube goes down all the way in to where it touches the hotter parts of the hot end, and it has a melting temperature, or at least a deflection temperature, that's in the 250-ish range. So too much above 240 and you might have troubles in the hot end. But this should print. Now it does want a bed temperature at 80. This Ender 3 bed might have trouble getting all the way to 80, but you can get away with a little bit lower one. So this PETG in general, though, you should be able to print on a Ender 3. And what I was going to say is that it's a good next filament because PLA prints pretty easily. It doesn't really warp, and it can warp, but it's not as bad as some of the other materials. And it doesn't need an enclosure and all that kind of stuff. But it can be strong but a little brittle. PETG is a lot more tough. So it has if you think of the area under your stress strain curve, there's a lot more area under a PETG curve than there would be like under a PLA curve. And so it's a little more tough, and since it prints and has a higher glass transition temperature than PLA, it can endure a little bit more heat than PLA can. For instance, if you print something in PLA, we're in the summer down here. If you took that thing and put it on the dash of your car one of these afternoons, it would probably melt. It wouldn't melt into a puddle, but it would deform. Just because the inside of a car gets hot enough to not melt PLA, but exceed the glass transition temperature, and it starts to deflect. This stuff, it takes a little bit more to do that, so it's a little bit more resilient to heat deflection. This one does make the note that this particular one, this has carbon fiber chopped inside of it. It's mildly abrasive to the nozzle, so the nozzles that are on your printers are brass, and if you want to print anything that has filler in it, so this one has carbon fiber filler, but even if you want glow in the dark or wood filler or anything that's added to the base polymer, it's probably going to eat away the brass nozzle, and it's going to be difficult to control the prints because the hole that's in the nozzle is going to gradually get larger and larger. It may not even be round anymore. So if you plan on printing anything that has a filler in it of any type, even something you think is a soft filler or it doesn't make any difference, it probably does make a difference, and you need to switch over to a hardened nozzle. And all that means is you take a few dollars, go to Amazon and get a hardened steel nozzle, and it's a screw-in replacement to the brass nozzle. We'll do that someday on this one, just so you can see the process. There's a few little things about it that you need to make sure that you don't cause leaks, but other than that, it's easy to do. This is glow in the dark rainbow. So so it's different. It's gonna glow different patterns, and it's a PLA material. But this one, even this glow in the dark, you wouldn't think there's stuff in here that's gonna wear away your nozzle, but it even mentions that it is not mildly abrasive. It's just plain abrasive. I could see you print glow in the dark filament for maybe even just this amount, probably more than this amount, on a brass nozzle, and the nozzle will be larger diameter than when you started. What is this? I don't know what this is. Oh, it has glass fiber in it. This is a nylon glass fiber filament, so it's really ugly color, but this one would be an interesting filament for something mechanical. So if you were trying to get some strength out of stuff, actually this one's going to be tough. Probably, actually, the print temperature seems reasonable. The bed temperature seems reasonable. Probably needs a hardened nozzle. It does say to use glue stick. I can't believe this is actually nylon though, because nylon does not print this low typically. I have to try printing some of this and see what it does. If it's good, eSun is typically a affordable filament. I don't know how much a whole roll of this would cost, but this could be a good material for some mechanical properties. In general, when I want a mechanically strong type product, I use some PETG. Don't necessarily do carbon fiber PETG, but I do PETG because it's going to give you a little bit more strength than the PLA, and a little bit more ductility, which is usually useful, so it's not as brittle. Oh, here's a cool PETG that's sort of transparent. Kind of see it's a lot of the PETGs are shiny. PETGs like a 7-Up bottle, you know, a lot of stuff like that's made out of PETG. This one's reasonable temperature. It's lower, 230 is the high end, print bed at 70. This one makes the note that if you're using a PEI print bed, so I don't have one on here right now, but that is the magnetic bed that I want to add is PEI. And that PEI material, it really grabs a hold of material. It bonds with the print until it cools down, and then it lets go of it. Except for PETG, it might stick permanently. So PETG on a PEI print bed, you use some kind of release agent, and usually that's just glue stick. This would be interesting to try. I actually want to try this and see if we can get something useful out of that. And I'm skeptical that it's going to actually print very well. Oh, okay. The fibers are nylon. I wonder what the base material is. The base material looks like... it doesn't say. It could be a PETG base material. I don't know. I'll have to figure out what this actually is. PA, I don't know what PA is. But we'll try printing some of this and see if it actually creates any strength or not. So I get these little boxes every month because, because you get stuff that you wouldn't normally try out. It's pretty interesting. I think we're about out of time. Well, we've got a little bit of time. We're like 10 minutes or so. So if there's any questions, I can answer them. That should give us time. Here's the magnetic bed that I want to add. This is probably the simplest upgrade other than just like clipping on something somewhere. This one is about as easy as you can get. So I'll go ahead. I won't put it on today, but I'll show you what it is. So you get this, and this is the bed itself. Let's see. I can get all this open. And you get a big magnet. So a big magnet that you're supposed to stick on to the surface. So once you stick this on, it's going to do a couple of things. It's got some thickness to it, so it might reset your Z height calibration. So you might have to go and redo that. And then here, some of these, I think this is one, they do have a protective coating. So we do need to get that off of there. You don't want to print directly on this. And now this is PEI. And again, the benefit of printing on PEI is that, assuming you keep it clean, and I clean it with isopropyl alcohol, clean it with that, it will bond to your prints and really hold them down well until it cools back down. So you do have to have the bed heated for it to actually do the bonding process. Otherwise, it's just kind of sitting on there. So if you run the bed heated, then this will bond to your print, hold it down pretty well, and then when it cools back down, you take the bed off and you just flex it a little bit. So this is a spring steel. You can print on this side too if you want to, just on the spring steel side. Maybe you're printing PETG and you don't want it to bond to the PEI on here, so you just flip this over and print on the other side. You can do that, but it will release really simply. Like if you print something and come back to it and everything's cooled down, you will probably just be able to pick the part off of the thing, and it's just sitting there. So this, I do like this as an upgrade. The one, I don't know if it's the only one thing. The one thing you have to be careful of is when you're doing that first level, I would do the first level on this side in case I accidentally get a little too close and I scratch the surface. This side is just steel, so it doesn't matter if I scratch that. this side has that really thin coat of PEI, and if I scratch it, I'll actually scratch a mark into the surface, and then I've got a divot in my print surface. Other thing, you are now having to transmit the heat through this pad, this magnet, and so you might have to print a little bit hotter bed temperature than you were before. Same thing if you add like a sheet of glass on top. You're adding a little bit of insulation between the heater, which is on the bottom. You know, it's on the heater's actually underneath here. Some of these have the heater built into them, and some of them it's on the bottom. This one's on the bottom. And so you're adding some insulation between the heater and your print, so you might have to bump the temperature of your bed up 5 degrees or so to get the same effect that you had before you put that stuff on there. So I think we're probably good for today. All I'm going to do is I'm going to clean this, stick this magnet on here, and then put this guy on here, recalibrate Z, and probably go recalibrate the the bed mesh leveling thing, and then try out some of this whatever it was called, the glass fiber reinforced EPA. I may not print on I may print on my other sheet first. I may actually do this first, just in case this stuff makes a big mess. I don't want the big mess on my new surface here. So I might print on this one first, just to try it out. I'll also, I think that's probably all that we need for now that I think about it. Let's look and see what we've got. So next, we've got a couple of things. So next week, some extruder upgrades, some bed upgrades. That probably won't be the whole class, so I probably will have some other things in on that day also. This topic was actually scheduled way later, but there was interest in, looking at the firmware and what does it do, how did we get started with that. So if there's some other things that are interesting, I can always pull them up or add them to some of the topics that we're talking about, particularly this next topic. That won't take the whole time to talk about. We're out of time for today though, and let me know, either chat, Discord, email, whatever, comment on the YouTube video if there is something that you'd rather see coming up sooner. Then I've got it listed on our regular schedule here, and I'll see if it's something that we can put in earlier. None of these have to be in any particular order, right? We've done most of the basic stuff. Also, don't forget that we're closing in on some of the first due dates for things on the Moodle page. So don't forget to actually go and do some of those. Particularly the competition one is getting sort of close. I think it ends on the 21st. So don't wait too long on those. All right, I will see y'all Monday. See y'all Monday.